have a look at percentage yield. And to help our understanding of this concept, we're going to take a simple analogy of a farmer who is trying to grow some corn. So if I go down to the market, although I'm not a farmer, let's imagine I am in this example. There we go, buy a sack of corn seeds, and on the label of my bag it tells me that this is enough corn seeds to produce 5 tons of corn. So the yield, or the amount I'm expecting to get, is 5 tons. So as a farmer, I go out to my field, I sow my seeds and I leave it for the season, whatever, and at the end of that process I find when I harvest my corn that I've actually only produced 4 tons, which is not quite as much as I was expecting to. So in order to work out what percentage of corn I produced in comparison to what I was expecting to produce, we can calculate something called percentage yield. Now in this case, to work out percentage yield, very simple, I need to take the ratio of what I actually produced, which was 4 tons, to the amount that I was expecting to produce, which was 5 tons, and then to turn that into a percent, I'm going to multiply it by 100, and in this case that gives me 80%. So what does that number actually mean? Well, that means I produced 80% of what I was expecting to produce. And because I'm not a farmer, I don't know if that's good or bad, but I think it's very unlikely that a farmer ever produces 100% of what they were expecting to produce. And it's worth pausing just to think about the kind of factors that might have impacted the yield in this case. So, for example, things like bad weather. In the UK, I know that's a significant problem, and that can cause big impacts on the percentage yield. We might have things like pests eating the crops, or maybe disease in my crops, and all of these factors, which are probably all going to happen to some extent, are going to impact my percentage yield. Now let's see if we can apply this analogy to a chemistry specific example. So in this case, let's carry out a reaction. Doesn't really matter what the chemicals are, but if I do some calculations, I can work out that the expected yield, or the theoretical yield, if everything goes perfectly, is 1.62 grams. So if I carry out that reaction, let's imagine I am heating those chemicals together in a round bottomed flask using a Bunsen burner, and once I have collected my product at the end of that process, I find the experimental yield, or the actual amount that I collect, is 1.24 grams. So using exactly the same layout as the farming example, we're going to try and work out the percentage yield by taking the ratio of the experimental yield to the theoretical yield and multiplying it by 100. If I stick my numbers in here, I get 1.24 divided by 1.62 multiplied by 100, and that gives me 76.5%. And you'll notice here that I've kind of been a little bit careful with my significant figures. The two values that I've used, 1.24 and 1.62, both have 3 significant figures, so I should probably give my answer to 3 significant figures as well. So we've got 76.5% of what we expected to get, which is not great, but probably not terrible either. And it's worth, again, pausing and considering what kind of factors might reduce the yield down from 100%. So in this case, there's a number of things that we can consider, and this will depend a bit on the type of reaction that we are carrying out. A common factor that might cause some problems is an incomplete reaction. Maybe I haven't heated my chemicals for long enough, so I've effectively stopped my experiment before it finished. I might also have a reversible reaction, which means that I will never produce 100% of the products that I expect to produce, because we have the backwards reaction occurring as well. Another factor could be side reactions occurring. So this is kind of unintended reactions between my chemicals, or maybe if I'm heating this openly with air, things might react with oxygen, for example, which means I'm forming some products that I don't want, but it might be unavoidable. Another factor might be the decomposition of chemicals during heating. Particularly if I'm heating something strongly with a Bunsen burner, Chemicals, that could be reactants or it could be the products themselves, might break down in that heat, meaning that I don't get all of the product that I was expecting to. And the final factor that we might consider is during the purification of my product, which could involve a number of different steps, I might lose some of that product along the way. And that might be a price we pay to get a pure product at the end. So it's also worth considering, occasionally we might get an experimental yield that is actually higher than the theoretical yield. So let's have a look at one final example. Let's do exactly the same experiment again. Here we go, we've got the same theoretical yield. I heat my reaction with a Bunsen burner again, and this time when I collect my product, I've now got 1.86 grams, which is greater than the theoretical yield that I was expecting. Now, because it's actually possible to produce more product than my reactants allow, there's going to be some other factors that we might consider. But first of all, let's work out the percentage yield in this example. Again, I take my ratio of the experimental yield to the theoretical yield multiplied by 100, stick in the numbers, and this time I come out with 115%. So what kind of factors might have caused an increase or a percentage yield that's bigger than 100%? Well, first of all, very common one, perhaps my product isn't fully dried, particularly if I've done my reaction in a solution. Before I weigh my product at the end, it's important to dry it. You might place it in an oven for a few hours or leave it out in the lab for a day or two. If you don't do that, there might still be water or some of my solvent in that product, which makes the mass greater than it should be. It might also indicate that we have some impurities in our product, which again is quite common if we haven't purified the product carefully enough. And a final factor to consider, and this will depend on the type of reaction you're doing, but sometimes by having an incomplete reaction, we may actually end up with a greater percentage yield, although this factor probably wouldn't be the case in the specific example we're looking at. And that's pretty much it for percentage yield. Hopefully this video was of some help.